Hey guys, welcome back to Genius Learning. So this is the second part of the quantum mechanics problem, part C. And so just to refresh your memory, this was the initial question, Hamiltonian. We found the energy eigenvalues, eigenvectors, right? And so now we're gonna move on to part C, right? And here I have a recap of everything. Hamiltonian, we have the energy eigenvalues we found, and the eigenvectors from the previous problem or previous video. Now part C is asking us if the system is prepared in an initial state, wave function at time equals 0 is equal to 1 over 0. This is in the Z basis in case you didn't know the notation, right? But it's prepared in this initial state, okay? Find the time evolved state, right, at some later time in matrix form, okay? This part here makes it a little tricky, but not too crazy. And understanding that they want us to, the system is prepared in an initial state, right? And so to find the time evolved state, we need to manipulate our values to match the initial state and to see how it grows over time. So first, we're going to set up, okay, similar to what we did for part B, but we already have our eigenvectors, and so now we're just gonna find the constants that will allow us to start off with this initial state. So A, we'll just, some random value. We know our eigenvector, our state, and B, another constant, so A, B, and then we know our second eigenvector. So these are the states that it can be in, and we want it to be equal to 1, 0, which is again the Z basis, but it doesn't matter. We just need to know that that's what we need to make it equal to. And for some constants, right, these two eigenvectors will give us the wave function at a later time, okay? So let's look for them. So let's replace these states with the actual numbers that we got. And so here, for 1, we have 1 over, so let's just write it out. We got A, and we got 1 over square root of 2 on the outside. So I'm gonna put this over 2, and then we have negative I, and we have 1 on the bottom, right? So I'm just replacing the state vector 1 here, okay? And then plus B, okay? And 2, the state vector, we got square root of 2 over I and 1. And everything is equal to 1, 0, right, our initial state. And so let's do the math here. Let's add these up. So we have here on the top, we're looking at negative A, okay, plus B, and we'll take out the I from both of the top terms, okay? All that is over square root of 2. And then for the bottom, right, we have A plus B, okay? And these are both 1, so we don't have an I common, and we just have over square root of 2, okay? And all that is equal to 1, 0. All right, so let's do like we did for the other ones. Okay, we're gonna take the top first. So let's write down, we got the top, which is this and this. We got negative A plus B I over square root of 2 equal to 1, right? This top part equal to 1. And then for the bottom, we have A plus B over square root of 2 equal to 0. So all of this equal to 0. All right, so Now let's work with the top. Again, preference, you know. You can choose the bottom one. I'm gonna go with this one. Okay, and we're gonna solve. So I'm going to I'm gonna put this on the other side and distribute in the I. So I'm gonna have negative AI on the top plus BI, okay, and that's equal to square root of 2 that I put on that side. Further solving, let's isolate the A. So we have negative A. What do we have here? We got AI, right? And so this is square root of 2, and this is negative BI, put on that side. And then we need to divide by I. So negative A, right? Square root of 2 divided by I, negative B, and the i's cancel. So another rule that we need to know is that 1 over I is equal to negative I. It's going to be very important in the upcoming parts right now. Okay, so now we know that this part is going to be negative I square root of 2 minus B. Actually, sorry, this divides to the other side and turns into a negative. Okay, so I mistake. Here we divided by I, and we have an I up here, okay? And we divided by I. Okay, so this 1 over I is negative I. And so negative I that we already have there times a negative I that's coming along is going to be positive, right? But then it's going to turn into a negative. Let's see. Okay, yeah. Okay, so now let's distribute this negative to the other side, and we're going to get A is equal to I square root of 2 plus B. Okay, that's where the plus comes from. All right, we distribute that negative. So we have this. All right, A is equal to that. And we can solve for this bottom one here and get, if I put this on the other side, it's 0, and then negative B, so that's A is equal to negative B. Okay, so I have 2 now. Now we do things a little different. Okay, so we have this one, and we have this one. Now let's see what we can do with it. So let's work. Let's put things over here. All right, and put everything together. Okay, so let's see. We're gonna go back to, we're gonna put these two together, and we're gonna find that if I plug in this, this B, okay, so if I do negative A equals B, right? Then I can plug in here the B, and I can get A is equal to I square root of 2, and for the B I put negative A, right? When I put this A to the other side, I'm gonna get 2A is equal to I square root of 2, and then finally, let's work a little bit over here. Okay, I'm gonna isolate the A, and I'm gonna get A is equal to I square root of 2 over 2 from this part. Okay, so I'm gonna hold on to that. Now that I have that, I can plug this into here, and I could see how the B is gonna be the same thing but with a negative. So B is equal to negative I square root of 2 over 2. Okay, so let me see if we can see there. Okay, perfect. So I solved for the top one, right? I got a value for A. I solved for the bottom one. I got a value for A. I plugged one into the other. We got a value. And then I plugged it back into one of them. So now this is what we're working with here. Okay, so let's pay attention to these, and we're gonna use them over here. Okay, so let's put everything together. Our initial equation was this, right? And so this is what we're gonna be replacing. We have the values for A, and we have the values for the state vectors. So let's do that. I'm gonna do it in two different colors so that way it can be clear. Okay, so I'll take this one and this one. All right, so let's do the A first, and that's gonna be that's gonna be I square root of 2 over 2, all right? And then let's do the state vector 1. We have 1 over square root of 2, negative I, 1, and now we have the second part, which is plus B. B is negative, so I'm gonna write the negative out here, right? And that's gonna be I square root of 2 over 2. That's just for the B part, okay? And now our state vector 2 is equal to all of this. So let's write that in the inside. Let's write 1 over square root of 2, I, 1, and let's close it off like that. Kind of did opposite, but you can distinguish that this is the A, this is the state vector, this is the B, this is the state vector. Okay, and all of this needs to equal 1, 0. All right, so now I'm gonna cancel out some things. So I'm gonna cancel out here, and I'm gonna just write the next line. So I over 2, and then in the inside we have negative I, 1. Here I can cancel out the square root of 2. I got negative I over 2, and I have I, 1, right? Okay, so we're almost there. Now this is the part that gets a little tricky. So what I want to do here is pull out so from here I want to pull out the negative I. Okay, so let's see. What I'm going to do is I'm going to pull out the I first. Let's just pull out an I from this one. And so if I do that, I need to pull out an I from the bottom one. And so this I stays. I'm gonna pull out this I from the top, right? I still have my 2 on the bottom. And now what I'm left with here is just a negative 1. And what I'm left with on the bottom is a 1 over I. Since I didn't have 1, I have to put an I on the bottom. Okay, and similarly over here, I wanna take out the I. And so I have the I that's already there, all right, over 2. I wanna take out this I from the top. And so I'm left with 1 on the top, and the bottom didn't have 1, so now I have 1 over I on the bottom. And all that is still equal to 1, 0. And so now those 1 over i's are gonna equal negative I. So remember our formulas here. So we have this here is gonna be equal to negative 1. So negative 1 over 2. And here we have negative 1, and down here we're gonna have negative I. Okay, so on this side, this is gonna be a positive, so I times I is negative times a negative, so that's positive 1 over 2. And then I have 1, and I have a negative I down here. Okay, so this is still all equal to 1, 0. All right, so pulling out the I made these down here 1 over I, and 1 over I is negative I. Okay, and so now from this side we can pull out a negative from both of them, making this 1 over 2, 1 I. And then here we can pull out a negative from the bottom, and since this top part didn't have a negative, right? I need to write a -1, and I'll just leave the I down there like that, right? Because if I distribute this -1/2 back in, the top part gets positive, the bottom part gets negative, so it's the same thing. Okay, let me just distinguish all of these. And then finally, let me try to do this in one more step. Okay, so then finally, you can see that the top part, I'll just write it out. So we're gonna have 1/2 on the top, and then I over 2 on the bottom, right? Let's see if you can still see here. Yeah, perfect. Okay. Minus, we have, if I distribute that into the top, I'm gonna have plus, so plus 1/2 on the top, and then a minus I over 2 on the bottom equals 1, 0. And finally, you can see 1/2 plus 1/2 is equal to 1. And then I over 2 plus a negative I over 2 is equal to 0. And so we have exactly in matrix form the time evolved state. All right, so let's so we have the vectors, we have the constants that we need. Now let's write out the time evolved state properly. Okay, and so we have the wave function at a later time is going to equal e, right, to the negative I e naught t over h bar, right? E naught because that is the first eigenvalue that we got, okay? And this has a constant in front of it. The constant's going to be exactly what we found, so 1/2, and then we have 1i. So we have this over 2, and then the state vector is going to be this, okay, exactly what we had here. So we'll use this one here. This next step was to show that it equals that, but this is exactly how we're gonna write it down here. And then this, right, minus this over here, we have e, right, to the negative I 7 e naught, because that's what we have for our eigenvalue. All right, t over h bar, and then we have 2, and for the state vector we have -1 and I down here. Okay, and so this wave function here represents the time evolved state, and it represents it specifically for how we need it, which is prepared in that initial state. Okay, so we made sure that our constants, right, that we set out to look for exactly matched the initial state that we needed it to. Okay, and once it did, that means that those constants, right, the A and B, were exactly what we needed for our time evolved state. Okay, so it's important that you need to match the initial state and that your constants work out. Then we can apply our time evolved state, which is just putting our exponentials and then the proper eigen energies that we found earlier on the top. Okay, so yeah, that's how we do that. Thank you guys for watching. I hope it helped.